All right, so today we're going to be talking about adding and subtracting rational expressions. So up here, we've got these expressions right here. Now, this is going to follow the same rules as fractions. So if I had a 3/4 plus a 7/4, in this situation that you've got both the denominators are the same, we can just add going straight across. 3/4 plus a 7/4 is a 10/4. Now, after you've done an addition, it then also helps to check to see can it be simplified, which that one can. We could simplify that into 5/4. We're largely going to do those same steps here in this problem. We notice both of them have x in the denominator. So I'm still going to have 9x as the denominator. Up top, I'm just going to combine the like terms. So I can add my x plus 2x, and I will have 3x, and then the 2y plus the 5y, and I have a 7y. Next, I want to quickly just make sure that there's no simplification that can happen. So while these two have x's, that term does not have an x, so I can't take an x out of everything. Both of those could be divided by 3, but once again, the 7y cannot be divided by 3. So there are no common factors. That one's as simplified as it will get. Okay, in this next one, very similar story. We have got the same denominator. So as I subtract these, I'm still going to get 6x to the power of 5 in the denominator. This minus, though, is important. You are not just subtracting the 3x that you see right there. You are subtracting both of them. Okay, so we would need to change the signs on both of them as we rewrite this. So I'm now going to rewrite this as 5x minus 6y, and then we were minusing a 3x, and then we were also minusing that 4y. Okay, so pay attention to that when your two fractions are being subtracted. Every term in that numerator needs to be subtracted, which is going to look like changing the sign, because if we were subtracting a negative is just like adding, so we'd change it to plus. If it was already a positive, then we're going to write it as subtraction. Okay, and now we can combine the like terms. 5x minus 3x is 2x. Negative 6y minus 4y would be a negative 10y. And then we've got 6x to the power of 5. Now, as far as variables go, while these two have an x, that term does not have an x, so I can't take out any x's. However, I do notice all of them are even. All of them are divisible by 2. So what I can do is take a 2 out of everything. You can think of this as similar to when you would have a 10/4, and then we divide the top by 2, divide the bottom by 2, and that gave us 5/4. And I don't or a 5 halves. And I don't necessarily like that way of showing it. I prefer to say that 10 was the same as 5 times 2. 4 is the same as 2 times 2. And 2 over a 2 is a 1. Okay, that's basically the same thing that's happening here. We're going to have a 2, and we've got x that's being multiplied by x minus 5. So I took the 2 out of the numerator, and now I'm taking the 2 out of the denominator, and 2 over 2 is just 1, and 1 times anything is just itself. Now, of course, I did show a lot of work to get to that simplification. I don't necessarily always need for you to show that step, but definitely in however you want to do it, I should still be seeing this step that was written right there and this step as you show your work on your assignments. Okay, so now we're to a place that is kind of tricky. These denominators are not the same. I cannot just add straight across. In order to make this work, I need them to be the same. So let's look at an example of like a 5/8 plus a 7/12, and I want to add those. Now, usually in the past, you've been told you need to find the least common multiple. The least common multiple. And the way that looked when you did it, you'd have 8, 16, 24, 32, 40, 48, 56, and then you'd also do it with the 12. We'd have 12, 24, 36, 48. And while we do have a common, we do want to go for the least common multiple. So I could multiply all of the 7/12 by a 2. And I'd just get 14 28ths. And the 5/8 by, looks like a 3. And we'd get 15 28ths. And now I can add those. We need to do very similar steps here. That can be tricky, though, in figuring out what we need to multiply by. So in order to do that, I would suggest making sure to factor everything you can. Now, of course, 3/2, that's not going to factor much. So I'm going to leave my 3/2 just like it was. This fraction right up here, the 2x doesn't factor. However, on the bottom, I could factor out a 2. We've got x plus 2. Now, notice what they do have in common in the denominator. This has a 2 in the denominator. This has a 2 in the denominator. What we're lacking in over on the left side is an x plus a 2. So if I want their two denominators to look exactly the same, I'm going to multiply everything in the left side by that x plus 2. Okay, so the numerator and the denominator. Over here on the left, nothing is really going to need to change. But notice, because I did that multiplying the numerator and denominator by the same thing, now our two denominators are exactly the same. Okay, so if you factor everything and you identify each of your individual factors, you just need to look at which of the factors is this fraction missing, and then multiply the denominator and the numerator by that factor. All right, so now we can rewrite this. I'm going to do distributive property, and I'm going to combine the fractions in the same step. So we'll have 3x plus a 6 plus the 2x all over the 2x plus. Oh, I made a mistake. Dang it. Hopefully, some of you caught it and were screaming at me over this. That should have been an x plus 1. Okay, so that 2 times x was 2x and 2 times 1 was plus 2, or was, yeah. Which also means that I now need to change this. Problem with not having students right next to me, there's no one to tell me that I just did something stupid. And no one tells teachers that they've done something stupid better than a room full of teenagers. All right, so 3x plus 3 plus the 2x all over the 2 times x plus 1. And now let's just go ahead and combine our like terms. So we will have 5x plus 3 all over 2x plus 1. I'm leaving everything factored on the off chance that I might find something that'll simplify. Please remember from the previous units how we always wanted to factor everything in order to find those things that could eliminate. I don't really see a way of factoring my numerator, so that's as simplified as this one is going to get. Okay, so now once again, same kind of thing. My 5p over 3. Nothing much to simplify there. Nothing much to simplify with that. A 3p plus 9, I can factor that and change it into a 3 times p plus 3. And now I notice this denominator has a 3. That denominator has a 3. However, this denominator also has a p plus 3, so I'm going to multiply everything in my first fraction by a p plus 3, the numerator and denominator. So I'm going to have a 5p, p plus 3, all over 3 times p plus 3. Subtract. And now that we've done that, both of them have the same denominator. So now we'll get my 5p squared plus 15p minus the 3 all over 3p plus 3. Okay, and now for the top, I want to check to see if there's any way of factoring that. So I'm just going to quickly check. Maybe it does factor nicely, maybe it doesn't, but we should check. So 5 times a 3, I'd have a 15. Factors of 15 would be 1 and 15, 3 and 5, and I would be looking for numbers that could easily be used to create a 15. None of those really will. So this would not factor nicely, so we're just going to leave it at that. And that will be our final simplified answer, because I can't factor that by grouping. Okay, in this next one. And I will say that if you really wanted to find if there were any factors, what we would then use is the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You'd use that here to identify what your zeros would be, and then that could help you factor further. However, I'm not sure because I haven't actually done it yet with that, but I would suspect that we might have some imaginary roots there. Okay, which wouldn't really help us in the process of simplifying. Okay, so now in this next problem, I do not see that anything can really be factored. This one has a 3p plus 1. This one has a p plus 6. So what we're going to need to do now is make sure that the first fraction has a p plus 6 as part of it. So I'm going to multiply the numerator and the denominator. Notice the parentheses that I'm going to put around the factor that was already there in the denominator. Okay, now minus, and then we need the right side fraction to have the 3p plus 1. So we're going to have 5p multiplied by 3p plus 1 all over 3p plus 1 multiplied by p plus 6. All right. So now that we've done that, both of our denominators are exactly the same. They have the same factors. Essentially, we just took the denominator of the opposite one and multiplied it to the numerator and denominator of the opposite fraction. Okay. So now, let's write this out. We're going to have 3p plus 18 all over 3p plus 1, p plus 6 minus, so 5 times 3 will have a 15p squared plus 5p all over 3p plus 1, p plus 6. Now remember that minus needs to go to both. So we're going to have 3p plus 18 minus 15p squared minus 5p all over 3p plus 1, p plus 6. Okay, let's combine the like terms. So I will first put my negative 15p squared, and then a 3p minus a 5p, we get negative 2p plus the 18 all over 3p plus 1, p plus 6. All right, and once again, I'm just going to quickly see if I can use some factoring by grouping to factor my numerator up here. So I would try to do a 15 times an 18, which would be 270. Factors of 270. And I'm not going to go through all of them, but even the one that would be closest, our 15 times 18, doesn't help us to get a 2 there. So our factoring by grouping method here is not going to work. Therefore, I'm going to go ahead and say that that is as simplified as that one gets. All right, so once again, our denominators, we have that as a p minus 3 as a factor, and we've got 3 as a factor. So I'm going to multiply all of the first fraction by a3. And then all of the second fraction is going to get multiplied by p minus 3. So now we've got the same denominator. So we can do 3 times p is 3p plus 18 plus 6p minus 18 all over 3 times p minus 3. Okay, combining like terms, we then get 9p all over 3 times p minus 3. Both 9 and 3 are divisible by 3, so we then have 3p all over p minus 3. All right, so final ones probably have a bit more of a challenge here in this one. So let's go ahead and get started. First fraction, I don't notice anything that I can really factor in that. Numerator here. This bottom, right off the bat, I notice I can take out a 2. I've got r squared minus a 1. Now, r squared minus 1, that's another thing that I know I can factor that. And so I'm going to do this a couple different ways. So one, I will show what that factors into. Let's go ahead and get that first. So this is a difference of squares, so that's an r minus a 1 times by an r plus a 1. All right. And so now let's look at each of our factors that needs to be taken into account. Okay, so we've got those 3 factors. Everything is going to need these 3 factors in it. So I now need to make sure that I multiply the left side by a 2, an r minus a 1, and an r plus a 1 to its numerator and denominator. So I'm going to write 4r plus 1. And so here's kind of where I'm going to do something that may look a bit weird. I'm going to go ahead and rather than writing 2 times r minus 1, r plus 1, I'm just going to write the 2. Actually, let's even do just 2 r squared minus 2. Now, the reason I'm doing it without it being completely factored is this multiplication is going to be easier. So rather than having 1, 2, 3 different multiplications that would need to be happening, since this is the same as that, I'm just writing what was above. That way I'm only going to multiply once. However, on the bottom, I'm going to go ahead and have my 5, the 2, and on the bottom, I'm going to leave it fully factored out. And my reasoning here as to why I would do that is when I reach the end, in case there's something to simplify, I want this already factored. I don't want to be refactoring later. Okay, and then the r minus 4, that one just needed to be multiplied by the 5. And then same thing here on the bottom, we just needed it to be multiplied by the 5. Okay. That was weird. So now we need to actually perform these multiplications in the numerators before we can start adding things and combining the like terms. So on the top here, I'm going to have 8r cubed minus 8r. That takes care of those two. Then plus 2r squared minus 2. And that was those two all over. And we're just going to go ahead and rewrite that as a 10 r minus 1 r plus 1. And then we'll get 5r minus 4, 10r minus 1, r plus 1. All right, and now just combining like terms, going straight across, because we are just adding, so I don't need to worry about any oddities there. So 8r cubed, negative 8r plus a 5r. And actually, let's start with the squared. Actually, just give me a moment. I'm going to double check. Yeah, so we just want plus 2r squared. And then we're going to have minus 3r. And now the negative 2 minus 4, negative 6. All over 10 r minus 1 r plus 1. And now I just want to quickly see, can my numerator be factored? So if I'm looking at 8r cubed plus 2r squared minus 3r minus 6, greatest common factor of the first would be a 2r squared, and we'd be left with 4r plus 1. We could pull out a negative 3 from both of those, and then we get r plus 2. I'm not really getting anything that's going to simplify there. So the factors here are going to be more complex than we are going to get at with our factoring by grouping. That's not to say that it's impossible, but it would require the use of the rational root theorem. We then need to figure out what are possible roots, input the number to see which could divide, then we need to use our synthetic division. We're going to leave it at that for right now. If you cannot factor by grouping, then we'll just leave it at that. Okay, or if you can't do a normal quadratic. So 2n over 3n. And in fact, before we get started much, I'm going to go ahead and just simplify those n's out. No need to make our lives more complex when something simplifies out like that. Top doesn't factor. Our denominator, I'm guessing, probably will. So if we do a 2 times a 5, that's a 10. We're looking for factors of a 10 that would make an 11. Well, 1 and 10. Okay, so we are now going to factor our denominator using grouping. So I'm going to do that over here on the right. So I'm going to write 2n squared. To create a minus 11, it would be a minus 1n, minus 10n, and then the plus 5. And now let's go ahead, take out an n from the first two, and that would leave us with n minus 1. We'll take out a negative 5. From this, we'll be left with n minus 1. That's the entire reason I wanted to take out the negative, is because I didn't want that to come out positive. Now that they're both n minus 1s, we know it factors to n minus 1 n minus 5. And I am missing something somewhere. Where did I make? With my 2. All right, so that was, sorry about that. Yeah, so that would have come out as 2n minus 1, and as we took out the 5, 10 divided by 5 should have given us the 2. All right, so that's how that factored, 2n minus 1. And n minus a 5. Okay, so I'm looking for unique factors. It looks like each factor is unique in each, so I need to make sure that the fraction on the left gets the 2n minus 1 and n minus 5 that it doesn't have right now, and we'll make sure that the right-hand side gets the 3 factor that it doesn't have right now. And just like I did over here, to simplify my multiplying, I'm going to go ahead and just multiply it by what it was initially, the 2n squared minus 11n plus a 5, not in factored form because we want to combine the numerator first and then try to refactor it later. So I'm just giving myself ease of multiplication there, and then 3 times 2n minus 1 n minus 5, keeping that factored so that if later on it simplifies, I'm ready for that. Minus 3 times the 5n plus 6 all over 3 times 2n minus 1 n minus 5. All right, so now we can go ahead and simplify these numerators. So we will have 4n squared minus 22n plus 10. And I'm going to treat this over here so like this was a negative 3, so we'll do negative 3 being multiplied by both of those. So then negative 15n negative 18 all over 3 times 2n minus 1 n minus 5. Okay, now for the top, we're ready to combine our like terms. We just have the 1n squared. Now a negative 22n minus 15n will get negative 37n, 10, and the 18, so we'll get negative 8 all over 3, 2n minus 1, n minus 5. Checking to see if I can factor out the numerator. So 4 times 8 is 32. I want to check the factors of 32 to see if any of them could combine to give me a 37. To see if I can do that factoring by grouping. So we got 1 in 32, and in fact, let's see, so then 2 and 16. It seems like any combination as we go lower, yeah, is not going to get us as high as a 37. So that's as simplified as that one can be. All right, that's what you need to know. Good luck.